Can you see the screen?
Yes, sir.
Okay. So last time actually we were talking about designing of pipeline thing. So as we were talking in the last class that to make a pipeline, you can get a standard pipe in the market, or if you will buy because one is two type of pipe, commercial pipe and just for household applications. So generally, if you want for household pipes, just 20 feet is, I think, the normal length in a particular shop. You can find a single pipe actually. You can find of different diameter, not the diameter you want. There are some standard, I mean, the sizes for that. So those are means available in the actually literature. If you want other than that, you have to especially ordered and all this, so that's a costly exercise. Nobody would be interested in that. Sometimes you might have seen that people are making the pipe with the help of rolled sheet by belting, because that's they make their own, because they are not having that particular size of pipe means available by any of the industries. So in that case, they roll the sheet and do the belting of that. They make their own. You might have seen somewhere in the roadside, then the people lay the big pipelines.
Hume
So
pipe.
if you might, yeah, Hume pie is also one a concrete one. So that's one thing. Also, I mean the metallic also is being done by the rolling the sheet actually. So that's one thing. So you are doing a belting there. So each type of thing, whatever additional thing you are adding to a single piece of a pipe or sheet will give some loss. So these are one thing that you make a pipe. Now you are connecting them. So to connect them, either you have to put a belting. Belting is one thing. So if you put a belting, so in case of failure, you will not be in a position to take it out a particular the segment. So you have to cut it down and join it. So that's create a problem. So belting is a permanent type of joints which creates a problem in case of failures, because you cannot take out the segment easily. So you put a socket. So socket is just like a small piece of a again a pipe which have threaded inside, sometime outside. So you can put a connect the pipe on that side. So I will show all of them. So before that, I want to see here show you the something, because once you have something is flowing inside a channel, you want to control the flow rate. So best flow rate you control every day in your home is just like your tap. So tap is also a valve. So that is sometimes you have a ball valve, a glow valve, a gate valve, a angle valve. So these are the different types of valves. I will show you all of them. And then you have a lift check valve, a glow valve, an angle valve. A check valve is just to make sure something is just to make forward flow, because then nothing should go to the backside. You might have seen that you might be lifting the water with the help of a pump to upside. So by chance your power went off, if you don't have a check valve in between, so all water will fall down actually. And whenever the supply will come, you have to again lift up same water up. So you are wasting that much power actually. Sometimes you don't want back mix also, so you need a check valve there. So just to make sure that whatever has bent up, it should not come down. Okay. So you have those type of valve also. You have foot valve. Have you heard the term so far a foot valve? Any one of you? Any one of you had the heard?
No, sir.
कोई गांव में नहीं रहता है? किसी के घर में या खेत में बोरवेल नहीं है? Yeah, you don't interact with your friends or colleagues who do the farmings and have this borewell. थोड़ा interact करिए public से, you will get some idea. So footwall is also one thing. It is being used in a underground actually pipelines or bore wells. So what it happen as wise means just talking that when you are the lifting of a particular fluid with the help of a pump. So water level, let's say, is currently groundwater level is, let's say, in Punjab or the Jalandhar is maybe 120 feet, right? Down the earth, down the top surface. So you have the pumps. For each pump, typical pump have 30 meter of 30 feet of the lift, means a pump can lift the water down up to 30 feet only. But water level is at 130 feet. So how to compensate that? So these days the people have come up with new idea of submersible pump. For pump directly they are putting inside at 130 feet. Okay. So that's one thing. That is the submersible pump. You are directly putting inside that. Another pump is that you are not putting inside that much deep. So you are putting some between of, let's say, the 60 feet down or 30 feet down of the earth. So what you have below of that, you have a pipeline which will be dipped inside the water, and on some side or off of that, you are fixing your pump actually. So in between of that, you have that much of the segment. So what you have there, you are putting a valve there. So in, the initially when you lift up the water in the beginning, you have putting a heavy suction force or suction pressure actually, so that it can lift the water from the ground level. After that, you are fitting a valve there all the time. Whenever you turn off the pump, that valve will immediately shut down, so it will just stop backflowing of water. So this is the purpose of foot valve. So I would show you the how does it work also. What each of the things would do, everything whatever you are fixing in the pipeline will give some loss in your pressure actually, or energy loss actually. So therefore this is given here, the losses here. Losses is in terms of energy, and now this energy is just because you are calculating energy. So those are being calculated in terms of length upon the diameter of the straight pipe length. So how do we correlate that? That is there. So this is what your loss formula. In the bottom, you can say the H head loss in meters is given F L upon D V square upon 2G. What does it mean? LE upon D equivalent actually. This is LE equivalent upon D. What does it mean? That if you are fixing a gate wall is giving you the loss which is equivalent to this much length upon diameter of your straight pipe. Means by chance you have a pipe of, let's say, 10 meter. If you are fixing a gate wall, it is giving a length which is equivalent to this 8 L by D of straight pipe. मतलब आपका जो length है वो L by D 8 और आप बढ़ा दीजिए, so that much loss would be given by your gate wall. Did you understand this term? आपने gate wall जो लगाया, whatever gate wall loss is given, that loss would be equivalent to your pipe which you will extend by this length. Okay? Can anyone respond something?
Is that D upon is that D thing is
This is
diameter?
the diameter of your pipe. This is calculate with respect to
Diameter
the
of which
diameter of
pipe,
the
sir?
pipe. मान
Gate.
लो आपके पास एक पाइप था, original pipe जो भी था, it has the some diameter, fine.
Yes, sir.
So it has the some length. Fine,
Hmm.
that the beginning. मान लो जहाँ let's say आपके पास जो for the rough side you have diameter जहाँ let's say 10 centimeter and length is the 100 centimeter. So एक आपके पास में pipe है. You have put a
Okay,
gate
sir.
wall to that particular pipe. Now
Okay,
gate
sir.
wall will give you the loss which is equal to LE by D8. But this term would
Okay.
be given by 8. That is the loss given by gate wall. So you already
Sir,
got
so
LE by D term.
this quantity always corresponds to that pipe through which we are connecting that valve, gate
Yes,
valve
yes,
or
that
anything.
pipe the connected to that only. No matter what is
Okay,
the
sir.
pipe you are connecting, be it a 2 meters of diameter, be it 100 meters of diameter, be it 10 centimeters of diameter. Okay, so this
Okay.
would be always
Okay, sir.
equivalent to that only. Based on that, you can calculate LE by D is 8. So if you know the diameter of the pipe, you can calculate the length. Okay. So I will show you this actually, and
Okay,
then
sir.
you are putting various type of band and all this. So each of them is giving some losses which is equivalent to these values. So practically you need not to mean that remember that, but for interview sake of purpose, you should know some idea Which one is giving more? So if you say gate valve is giving less, 8. Globe valve is just, let's say, 340. Angle valve is 150. And highest is coming for this check lift valve is 600. So just magnitude wise, you should know at least some idea which one is highest, which one is minimum. Okay. Now this is again, these are the various components which also need to be used in case of pipes. Elbow. Elbow, just like the example of your elbow only. Elbow is just to use to just to change the directions. That short elbow, long radius. So I would show you all of them. This also gives you the loss coefficient. So practically the previously which we are talking this now, this LE by D, B square upon 2G. So this complete thing F LE by D can also be the replaced by a loss coefficient. This total term F LE by D can be also be equivalent to the loss coefficient, which is called a KL. So KL is equivalent to your F LE by D. So either you need LE by D, or if you know the value of KL, you can also calculate your losses. So these tables would also be provided to you, and these are the corresponding loss coefficient values uh, for various type of fittings. These are called fittings. Anything else other than your the straight pipe is called fitting actually. Be it elbow, be it a band, be it a T. T is just a 3-point connections. Just like a T, you have two inlet, one outlet, or maybe you have three connections in that actually. T. You have a union, is just like a pipe connections in always in all pipelines. You put a union. Union is just a type of joint in which if the something fails, that you just unthread it, and you can take out your pipe and you can then replace the new pipe. So I would show all those figures. You will understand all of them carefully. Now you have a globe wall, gate wall, angle walls, and closing 1/4, 1/2. So each of type of closing will also give the sum the losses actually. And you see the one thing here, swing check wall, backward flow. KL is infinity. Backward flow means you are checking the backward flow, means you are not allowing any backward flow. Therefore, the loss coefficient is infinity. Nothing would go back. Therefore, the loss coefficient is infinity actually. So these tables and values would also be provided to you in order to design the pipe. Now I would show here one by one each type of fitting to you. This fitting is called re-entrant. Can you see the figure? This first one, this side is, let's say your container, and somehow you might have seen a particular person has put a connection in the container, and he made it some wrong fitting, and उसने थोड़ा pipe अंदर fit कर दिया. You might have seen that type of thing, na? Okay, you have some pipe inside, and this side he has welded something. So this type of connection is
Yes,
called
sir.
re-entrant, and this have the loss coefficient is, let's say, 0.78. A person has made a very good fitting and he has just made this, nothing is coming out to the fluid, and here, so in this case your loss coefficient has drastically decreased. You see the previously 0.78, nearly 0.8 here. Now here 0.3, you have changed by 0.3 magnitude. So, but this is just a carelessness of a person, right? So he has just, so what is here lost? The fluid will come first here, then it will move this side, then it will move. So you have having so many change in the direction of the fluids. So too much change in the direction of the flow pattern would give you the more amount of the losses here. Now you see one more type of connections. Here you have a sharp change, 90-degree change here. You have the loss coefficient 0.5. Now here's rounded one. You did the rounded one here. You see the loss coefficient had decreased drastically here, almost half of this. Purpose is same. You are connecting a same diameter pipe just to take out the fluid, but only thing the diameter is same, everything is same. By changing the direction of the flow from a rough side to the smoother one, you have decreased your loss values. So loss value is just 0.28 now. If you will just increase your value of R more and more, your this loss value is the decreasing to a very low value, 0.15. Now this is value you see 0.04. You are almost negligible in the losses. A best example you can take from your car example. If you are going in the straight side, and if you want to take a 90-degree turn, you cannot take it. So you have to stop the car almost, and then you can turn it only 90 degree. So your all energies is going based by putting a brake. If you are taking a curve, now curve the depend how much is the radius of the curve. More is the radius of the curve, less would be the wasted of your power of the engine. Correct or not?
Correct, sir.
The same thing happens
Yes, sir.
in case of flow of that. Means you should not disturb the flow pattern, whatever flow pattern is coming. Everything wants to move in a straight pattern. If you want to change that patterns, you will always have a loss. Okay. So therefore, your loss coefficient for re-entrainment is 0.78. Square age is 0.5. Rounded one, the depend on this value of R, and this become constant if this value of R by D is greater than equal to 0.15. This value is fixed 0.04. So now if you know the loss coefficient, this is the formula just to calculate the loss created by each of the fitting. If you know the value of K, just put here K B square upon 2G term. You can calculate your loss in terms of meters of fluid. Okay. Now exit loss for re-entrainment, sharp edge, slight rounded and everything is exit loss is always one. Means what do you mean by exit loss? There would be a loss in the entrant from where the fluid is entering. There would be always a loss at the exit end also, this end also. This would also give the loss. And generally this is independent of what is the type, whether you have here sharp exit here just like this re-entrant, or any shape, either you bend it, smooth it, or either you curve it or something like that. All the time exit loss coefficient is 1 only. Okay.
Okay, sir.
Now this is again this pipe diameter thing we have already shown here. Actually for you, this is the giving you the value of the roughness by D, epsilon by D, and these are the diameter the table. So if you know the diameter of the table, you can calculate what should be the value of the epsilon by D, and this is for various the materials available worldwide actually. So your drawn tube, you have commercial steel here, wrought iron also, you have asphalted cast iron, then you have this galvanized iron, then you have cast iron, then you have concrete, board, riveted steel, which I was talking to you that from the metal sheet by putting the rivet. Have you seen the riveted sheet in your sheet metal shop in your workshop?
Yes, sir.
Riveting part you might have done to might have you might have made funnel or some rolled about thing, so you can put a rivet type of thing. People used to use earlier time that cobbler used to use the rivet just to make your पर्स में एक पिंच लगा देते हैं, दो पिन लगा दिया and ठोक दिया उसको, right? That is called the rivet only. And so for that you need a hole, and a hole ke andar you need two pins from both the end. One is actually female, one is male. Just punch them up, and that is called the actually the rivet. Okay. So these are the various means. So this is again a graph for the same thing which we have talked the previously. So this is the rounded means actually you can say entry here, and there's the sharp edge exit here. So this is KL by D table for that. This is KL, this is R by 2. So this graph also can be used. Same thing for this. This we have already shown to you. So here you have a circular part here. So based on theta, that how theta divergence is. So if theta divergence is very far, very fast actually, your fluid will not be in contact of the walls of the tube, and you will have a circulation of the fluid in case of gap there. So the losses would drastically increase. So you should diverge the fluid or anything slowly and slowly, so that your fluid would should always remain in contact of the surface in order to avoid your eddy current. Eddy currents mean the circular flow patterns in the fluid. So that is unwanted, because once you have a circular flow pattern, your fluid will be trapped permanently in that particular loop. It is not coming out, it is keep on moving, and moving things means you are always losing some energy. So that's eddy currents is always unwanted, and that happens wherever you have flow separation from the surface. Okay, so this is another chart to calculate this KL with the help of the theta only. Now this is what you have here. You might have seen ये अभी सारी जगह छूट गया है, आपको रियल लाइफ में दिखता नहीं कहीं भी. So this is also there कि आपके पास एक पाइप ये आ रहा था, and you want to change the direction. तो आपने एक ये 90 degree sharp change means you have put a 90 degree जो है sharp change. So this is also a called some sort of T only, means this is some sort of elbow, 90 degree elbow actually. So this you can say here the sharp edge here. So what you have a flow pattern with streamline here. Now you see here in this particular part, this streamline, whatever is coming here, just follow this particular path. Now there would be a fluid in this particular colored zone here, which is permanently trapped. It is not going anywhere actually. So this would create a flow separation, because this fluid, because as you have a sharp change, you can say in your tap also, wherever you have a sharp change, the fluid will not be falling just straight forward downward. It is somewhere far away. So this type of flow separation will always give the high amount of error actually, or losses actually. Practically losses, not the error. So this case the losses is high. You see the KL is 1.1. Now you see here in this particular case, design is same. Only thing in between of that, you have put a sharp curve plate. These are the sharp curve plate here, so that you are defining the direction of the flow. Now here you have just changed this direction, you have just changed a smooth change. Here the losses is tremendously low as compared to this, nearly 5 times lower than this case. So only thing, wherever you are the guiding the things in a particular means the directions and changes are smooth, your losses would become low only. So this is being followed in case of your in your heat exchangers actually. Now the next one is this band. Have you seen this type of band? Band is just a pipe. वो आपने सीधा एक slowly आपने heat treatment देके or sometime by hammering you have given a direction of band. You have changed the directions by maybe 30 degree, 40 degree, 60 degree, depending on the need. So have you seen this band somewhere?
Yes, sir.
Yes, sir.
Yeah, so this is the metal band
Yes,
भी
sir.
होता है, plastic band भी होता है. These days, all in household people do the plastic fitting, right? Nobody is doing the metal fitting. So you also have a band. Band purpose is just to change the direction. Previous fittings means also elbow purpose is also just to change the direction only. So we need the guiding things to just to change the direction. You see here the diameter is same top to bottom here. You see from in this particular side. Now here fluid is coming in. So if the diameter is same here, there would be no flow separation here. If diameter is getting changed at this particular end, you see at this particular point, fluid is, you are inserting flow this side, correct? Upside. So it would have the tendency just to move the upside. So due to this tendency, this fluid from here is is following a path of this side. So there would be again a flow separation in this particular part. So wherever you have a flow separation, you will feel this type of circulation path, and which will give this type of path is called eddy currents, which give the losses to the flow. Okay. So as far as this R would become more and more, your flow separation will keep on decreasing actually. So this is again the table just to calculate for your KL. And these are the actually I just give you the some idea that what could be the standard pipe size available in the market. This is the some table only. This is not all list. You will have an extensive list of 10 to 15 pages, which will give all the nominal pipe size. So if you will go to the market, and least pipe size you will get in the market is 1 by 8 inch pipe size, nominal pipe size. Nominal pipe size is not equivalent to the inside diameter of the pipe size. These are the different. So you see, if you will go to the market, if you ask in the market 1 by 8 inch pipe, uska inside diameter is this much, 0.269 inch only inside. Outside will the depend in the thickness of the material and wall thickness, and you are not interested in the outside one because you want to make the flow. So you are interested only inside diameter of the pipe. Outside diameter pipe depend on the material of the construction, and the depending on the what type of the pressure you are inserting. Based on that, you need a particular thickness to provide the strength to the material. Okay, so the nominal pipe size is practically is your OD, practically is your OD, and inside is this only. So this is the table, nominal pipe size of 1 by 4 inch. The inside tube diameter is 0.364 inch. So this is table up to 2 inch, then 2.5 inch, then 3 inch, 4 inch, 5 inch, 6 inch, 8 inch, 12 inch, and 12 inch. 12 inch and 10 inch. You can see the table here. You cannot see the pipe size here of the 11 inch. यदि आप कैलकुलेशन करके आपका diameter, if it is coming, let's say 10.5 inch diameter tube, inside diameter tube, you did all calculation for that. But आप market में जाके, if you will go there, you will not get 10.5 the diameter tube है ही नहीं. It's not available. So you are forced to recalculate with inside diameter 10.02 or 12 and recheck your calculation for your the pressure drop and all pump loss and all this. Okay, so if you are calculating a diameter which is coming equal to, let's say, 10.5, so you have to go to the higher one. So higher side available is just 12. So you have two options. Either you use 12 or 10.02. You cannot use 10.5, 10.8, 10.9 because that side of the diameter pipe is not available in the market or commercially anywhere throughout the world. So your design calculation of that way के जो भी answer आ गया जो आपने वहीं छोड़ दिया, no, it is of no use for anyone. Just like this, if you are calculating a diameter of 8 inch, 8 inch not available. You are available 7.9 inch. Getting the point? So you have
Yes,
to
sir.
always
Yes,
see
sir.
what diameter is coming from your calculation. Is it available or not? So you have to see this the table, and you have to always take a higher side of that. Mean by chance you are getting sometime a calculation, let's say 8.5. So 8.5 means that is coming from your flow rate. You cannot handle it. 7.9 will not work. So you have to go for 10. Or you have to recalculate it for the 7.981 and recalculate everything, because you have to calculate again. You will get new pressure drop. Once you will change the diameter, your pressure drop, your energy losses, everything would change. So you have to
Sir,
redo the calculation.
sir, is there any specific reason for like making standard on for this particular diameter?
These are the actually standard use worldwide. It is being standard. Yeah, actually to make the die, you have to make the pipe. You have to have a particular type of die or blowers, casting or molds. So these are standardized throughout the world actually, so that we should have some consistency throughout the world, so that people should not face any problem. Okay, so that's why these are being standardized.
Okay, thank you, sir.
Okay, and this is being followed from since beginning of all this, just to make a common consensus with all engineers actually. So we have come up with some standards. so that if you will I mean the design something in the USA and you want to implement in India, so you did the I mean the designing in the USA, and once you reach to the India and you came to know, okay, nothing mean exists of this size here, so your all design will get failed, right? So therefore these standardization has been done. So this is again the loss coefficient. So this is called actually a nozzle. Nozzle is practically from one side, inlet side is bigger diameter, and outlet size is the smaller mean the diameter. So either you can say the nozzle is just a small part, just this segment. If you have this end, then it is called a reducer actually. You are the reducing the diameter. So now you can the reduce it by this way, by the tapering here this way. You cannot have this end. Somewhere you can have only this particular part, only this one. So that is called a reducer actually here. So for this also you have the table just to calculate this AYD things and corresponding value of the theta and this loss coefficient KL. Now this is combined table of various type of the fitting. This we have already talked, re-entrant. This is a sharp edge exit. This is exit here. You see the fluid is coming from this side going to this side. This is a bell, the rounded one. This is again exit of the pipe, because from here the fluid is coming. It is getting exited on this particular side here, this one here. So here you have alpha value here. Then here you have this one, the sharp edge one. This is the rounded one. So rounded one is lower, and sharp edge one, for this case this alpha value is 2 here. The loss coefficient is the alpha value here, resonance. A laminar flow you are always treating here 1.01. So you will have always a entrance loss, you will always have a exit loss. And all of these are called minor the losses, because these are coming due to only fittings, not by pipe length. So this is what I was talking to you. This is due to sudden expansion. You have a pipe connection here. Now suddenly you have expanded the diameter. So in this case also you see here the fluid will go this side, and now there would be a circulation of the fluid in this corner and in this particular corner, and these two wakes would be formed, and these would be added to your the losses actually, due to which in your orifice type you have seen orifice is thus this type of connection here, sudden expansion here and the sudden contraction both, and there you have your discharge coefficient for the orifice is 0.61, only because of this, because you have this type of flow patterns in the exit side here. This is due to the sudden contraction part here. So here the fluid will follow this particular flow patterns, and whatever fluid will be trapped in this particular corner, it will always be in this corner. It will never go out. So this will form again a wake formation, and this will also give the addition to the losses actually, apart from the losses on this side due to sharp edge. This is again the gradually expansion and contraction. So this is the gradually expansion, this is the gradually contraction. So gradual expansion and contraction, your losses are minimized. But this costs a lot, because you have to do the tapering part. So this is also a costing to you at the manufacturing end, but less cost in operating end. So you have to sometimes you have to compensate the two. Whether I can compensate the material or the manufacturing cost, or I can compensate the operating cost. Operating cost क्या आएगा यहाँ पे? Your losses of pumping, that would be everyday loss. By chance you will run a pipeline, let's say once in a month or once in a year. So for that case, you can compensate your operating loss, because you are the running only once in a day or once in a month. So your operating cost is not that much high. By chance, let's say you will lay down a sophisticated instrument or pipelines and all this, and nobody is niche. So nobody is going to use, just like a building. आपने एक घर बनाया, you have put a highly sophisticated instrument, fittings, furnitures, everything, and there is hardly someone to live there. Correct or not? So in that case, you have taken care first thing, your losses, your power losses, your everything, but operating cost is very low there in that particular part. So you have put lot of money in the investment, that is called capital cost. Same thing here also in case of pipeline. You have taken care lot, but operating part is nil. You are not compensating those capital cost part. Okay. So that part we will talk the later on in process economics part actually. So this is again a combined part. This is what we need to make a pipeline. This is a band here. So this is a guided one. You have here a slightly a guiding band here. This is a sharp band. So this is called a 90-degree meter band. They have a particular name. So try to remember the name. What are these? At least try to draw them. इतना चीज आपको मीन्स आना चाहिए. If you a person will ask a smooth band, you should be able to draw this. Now this can be these two ends. These are the two ends which you need to connect to the pipelines. This could be either flange or thread. You can have a thread inside of that. You can have thread outside of these because you want to fit in the pipelines. So either you need a thread or you need a flange. Okay. Have you heard the term flange? देखा है flange?
No, sir.
No, sir.
ओ आप लोगों ने कुछ
No,
भी
sir.
नहीं देखा. कहाँ
No,
रहते
sir.
हो? जो है मतलब जो है इंडिया में ही पैदा हुए हो या कहीं और?
सर मे भी नेम से पता नहीं चल रहा हो, एक बार देखेंगे तो पता चल जाएगा.
कभी आप किसी का बोरवेल हो
Yes,
वहां
sir.
जाके खड़ा होना जरा देखना. फ्लैंज जो आपका पाइप होता है एक बड़ा सा, उसमें आपने देखा होगा एक दो प्लेट होती है, उसमें थ्रेड लगा के टाइट किया होता है नट बोल्ट से. देयर आर टू प्लेट्स, वन प्लेट इन दिस साइड पाइप, वन प्लेट इन दिस साइड पाइप, ए गोल्ड वन, और उसमें देयर आर द होल्स, देयर आर द नट बोल्ट जस्ट टू टाइट इट. अब आया समझ में कुछ?
Yes,
हाँ
sir.
सर.
हाँ. सो वो होता है बड़े बड़े पाइप में. यू हैव ए फ्लेंज. फ्लेंज के अंदर एक होल होता है. देयर द थ्रेड, देयर द प्लेट, देयर प्लेट में होल्स होते हैं जस्ट टू टाइट इट. दैट्स कॉल्ड ए फ्लेंज. So this is the meter bands and the 90 degree, and they're the guided one. So guided one have the low loss. This is the 45-degree threaded elbow. Then you have, this is called completely आपने डायरेक्शन को उल्टा कर दिया. This is called a return band or U band. Return band or U band, both are same thing. This is the T. Here three connections are there. So this is T. And this is again a T here. So this is here, you have changed a straight line. So line T. This is just a T just to change the direction of the flow. This is the most frequently used in the pipeline, a union. Actually, union is just to connect a two pipe, and there the socket here, this one. So this have two connections here. If you will open it, one side will go in, other side will also go to inside. So you can easily disconnect these two pipeline. By chance एक pipeline आपका worst हो रहा है, so you can easily take out and replace by the new one. If you are putting this elbow and this T, you cannot take out these pipe easily. So you have to dismantle the entire pipeline. So those are not allowed actually. So you are putting elbow wherever you have a chances of frequent failures. You are always putting the union here, threaded the union one, because this always give a gap. एक साइड से पीछे निकल जाता है, दूसरा पाइप you can easily take out actually. So this I can show you one day in the actually the lab by the demo also. Here I also have picture, but I can show you the demo in the lab. We have all these particular things. And these are corresponding layers coefficient for various type of walls here. So I would show you what walls are there. So this is first wall here. Sorry. This is forged steel gate valve. So what you have here, there the flow fluid will come from this inlet. There's the gate here. This is the gate here. This is the gate. So if you will open this stem by moving this, actually this anti-clockwise, so you are opening it actually, and this lever, actually this particular seat will move upside, and this fluid will move this side in this cavity and will go this side here. So this is the valve just to open and close your fluid. Actually, this is first valve is gate valve. There are the several component of that. So that is what I will ask you to just read the yourself, because I don't have that much time to explain how the valve acts and all this. So this is a gate valve. Another one is globe valve here. So in this case, this fluid is coming from this side, and it will hit this valve here, and then it will go upside and then again change the direction. So you see in this case, there are the several change in the direction of the flow. One is this side, first is going downward, then is going hit, and this is going to hit this particular disc of the valve also. So this will have high amount of wear and tear, the losses, compared to the previous one. You see the previous one, there are not much change. It will directly go here. If it is fully open, this will go completely upside in this cavity. This all these full seat will go to upside, and this will have full passes here. So it will easily flow in this particular case. Now in this case, this is going to hit in vertically upside. So in this case, the damage of this seat would be high. This case would also is high if it is not fully closed. If it is not fully fully open, sorry, so it will hit this particular portion of the gate. So it will hitting a 90-degree here, this side. Here, the 90-degree change is being decreased. This is also getting hit by the 90-degree, but you have already changed the direction here one time. So therefore, the magnitude of the impact on the seat would be low as compared to the previous one. Next is this plug valve. So plug valve is just a, have you heard a term a plug? घर में बिजली का सुना होगा plug, right?
Yes, sir.
Yes.
So plug में आपने just insert कर दिया something. So either it would be in two cultures, a on-off type of valve, right? So in case of this, this is the opening actually. This is the opening. So either you can make it fully open or a fully closed or a partially closed also. Is it just some sort of the packing there? You can move it actually. So this is a plug valve, and this is the valve actually. There's the wall here. So a wall here. So this wall, just say spherical, the metal ball. Inside of that wall, you are having a through hole, just like this here. एक hole कर दिया आपने. So once this hole is completely aligned to the pipeline, you will just straightly you will go into the entire flow will pass. You can just close the opening by 30-degree, 40-degree, 50-degree, 60-degree. So this is the actually a wheel here. On this angles are the mentioned on top. So you can close the opening by that much percentage, by 40-degree, 45-degree. So you are just the rotating the orientation, this the direction of this particular hole. Based on that, you are controlling the flow only. So this is the ball valve. Now this is actually again a few type of valve. A lift check valve here. So lift check valve is the something where you are not allowing a backflow. The check valve purpose is that just to stop your backflows actually. They can only permitted your forward flow and no backflow. Just in this case, by chance this pressure is high, this will push this particular the lift upside, and fluid will come out from here. As soon as the pressure this end would decrease, this lift will bend down, and finally your flow would close. So check valve purpose is just to make sure the direction of the flow only to a one particular side. They will not, just like this you see here. So in this case, once this pressure is high, it will move this particular valve upside and fluid will come out. As soon as the pressure will go down, this will just close this particular passing. So there would be no backflow here. So these are the some various type of the lift check valve. You have a disc here. And this is one I was talking. This is most commonly used in earlier type of all bore wells, just to have a lift, a foot valve here. This is being put in the pipelines where we want to suck the water from a very deep water tables, let's say 100 feet down or 500 feet down here. So this is one is disc type. So whenever this side you have a low pressure here, the suction pressure here, so this will suck this the lift outside up. Actually, fluid will come out from here. As soon as this side pressure will suction pressure will decrease, this disc will close down the passage and finally you will stop. Same thing here. This is one way here. This actually have also a hinge type of thing. This is connected here a plate, just like your door. आपका डोर ऐसे मूव करता है ना, बस just it move this way, right? So same thing here. By chance your vacuum is up, so the disc will move upside. When this vacuum is low, this will close. So this is also is being used a hinge type. So this disc will make sure that the bottom of the pipeline is always filled by the liquid only, so that whenever you turn on the pump, you are just creating a suction just to lift the only the disc, not to lift the water from 100 feet down only. Okay.
Okay, sir.
Now these are the various type of fittings is we have. These are the pictures of all of them.
Sir,
Yeah.
पॉप डिस्क को एक बार दोबारा बता दो.
Yes, yes. So this one, the poppet, the disc is just a disc which is fixed on some particular hole actually. So whenever this side you will suck by some vacuum, this lift will move upside, and so that this fluid will be lift upside here. It will cover continuously, will keep on coming out here. Here there is a position which is perforated seat here, because by chance you don't have this seat, you will suck the disc up and up. So this may come out completely outside. You don't want that. So you want just to make sure this lift should lift up to the some height. It should be they stand at a particular point. Just to be they stand at a particular point, you have a seat here with the hole, which will permit only fluid to go out. Disc will not go out from that particular point. Okay. As soon as this side you will turn off your pump, it means you are just decreasing the suction or your vacuum on the top side. Therefore, this particular fluid will not go up now. Now this top fluid will try to push it downward and it will close. आया समझ में कुछ? Just like के आपने एक ट्यूब ले लिया और ट्यूब को just
Sir,
like your
inject
the straw just to drink the cold drink. Cold drink पीते हैं आप? So cold drink पीते
Yes, sir.
time you have a pipe, plastic pipe, that is called the straw, right? So उस pipe में currently you don't have this type of thing. Neither you have a disc, neither you have a hinge disc. आपका डायरेक्टली एक पाइप है. तो जब तक आप मुंह से सक करेंगे तब तक तो पानी आपके मुंह में आ रहा है, करेक्ट? जैसे ही आप मुंह को खोलेंगे वो पानी सीधा वापस चला जाएगा, पूरा कोल्ड ड्रिंक वहीं का वहीं. करेक्ट और नॉट?
Yes, sir.
अब
Yes,
उस
sir.
पाइप में बाई चांस यू हैव फिट ए डिस्क, कि जब आप जो है सक करोगे तो डिस्क भी ऊपर को उठ जाएगा, and then your fluid will go continuously up till your mouth. As soon as you will open the mouth, जो आपका पूरा पाइप में पानी भरा है वो डिस्क को क्लोज कर देगा वापस. Yes or no? So your pipe would always have that much field of height of water, just to make sure कि next time आप फिर से sip लेंगे तो you are just putting a very less pressure. Will it help or not?
Yes, sir.
Correct?
सर ये सेम मैकेनिज्म हैंड पंप में भी यूज होता है क्या?
Yes, in all hand pumps. जो आपका हैंड पंप होता है उसमें इस वाला वाल्व होता है, ये वाला पपेट वाला वाल्व, this वाला पपेट, and in my place they say is गाजर actually, तो वो गाजर शेप में ही होता है actually. And but proper name is this actually, puppet disc actually. So जैसे ही आप पंप को डाउन करेंगे, हैंडल को डाउन, you are the sucking up that particular fluid up, so this will जो है lift up. जैसे ही आप डाउन साइड करेंगे, this will close the passes and your fluid goes upside. Okay, because the whatever has been the sucked up, it will not go down. Now you are pressing the downwards, your fluid is going upside. So this happens in all hand pumps and all the submersible pumps, all bore wells actually. Now these are the all fittings, not all, few of them. So you have here, this is one side thread, one side is inside thread, outside thread, and this is your, you have T here with threaded one. This is called the nipple, and the tapered one without any thread. You can, this is called insert type of the couple. So we will show them one by one here. This is one first fitting here, a threaded coupling. So you have a coupling, it's just to connect a two pipelines, and it have the inside the thread here. So आप एक pipeline जो है यहाँ से fit कर दीजिए, and the another pipe from this end. So this is called a coupling. You are coupling between two pipes with the help of this. So this is threaded one. This is another one here. These are called brass unions. So this may have the steel one also, and the other metal also. You have two type of thread here. This one, for this type of the union here, the first one, if something band fail, you cannot take out easily from here because this is fixed from both and it doesn't have any gap. Same thing here also. These are the just change in the size between 1 and 2. See this side here, this one. This is one side. One side is just a cap. Other side you have a thread. So the threaded one दूसरे pipe में fit हो जाता है, and the next pipe is just a clamp. So this side you don't have thread. This side you have a, how do I show? I will show here just a plate here, and then you have a just a metal sheet here. So वो one of the end को it just tight, other end is being connected by the thread. By chance you want to open it, so you just loosen this, so this will go back into the back pipe, and the front pipe can be disconnected actually. So this is the benefit of this one actually. So this is your elbow. So your elbow, typically this is your 90-degree elbow here. Actually, or the direction of the fluid, either you can have a fluid from top side or bottom side. So you are changing the direction here, 90-degree here. These are the elbows of the any side. You can change the angle by 40-degree, 45-degree, 35-degree here. And degree is being calculated from here. The initial side, they are vertically up. Now you want to say where the exit is going. So if you draw these two, this you are getting a 45-degree angle here. Now this is here a fitted one. This you see there is no thread here. So this is being fit by hammering only. Just insert kar dijiye by putting some force or some glue actually here. In this case you don't have any thread. This is also a T-shape fitting. These are called the reducers. Actually here this is called the centric here. The center line doesn't change. This is called eccentric here because here the center is being changed from the another side. These are being to say just to replace the direction of the flow only. Just to change by direction by let's say by 1 centimeter or 2 centimeter. So for that, we used to use the eccentric one. Then this is a plug type of fitting. So plug is one thing. The plug is just a dead end actually in there. You are just putting you might have seen in your household, there are the connections where you might have seen a metal ka nut laga diya hai wahan pe, right? Just to have a future connections, right? Have you seen those type of fitting? You have a T there, and
Yes,
there
sir.
you have a metal plug or a plastic plug just to make the future connections. So plug is a dead end. You are just inserting or making sure nothing should come out from here. So these plugs are there threaded also, without threaded also. Generally, people prefer the threaded one. Now this is another thing here. This is mostly is being used a Y-shaped one where you use a concrete pipeline where you have a larger the diameter pipeline just to change the direction of the flow. So this is Y-shaped one. Now, once we know all those fittings and all this, let's say we want to design a piping the network here. This is your typical picture of your industrial plant where you have several plant may everywhere you have the pipes. You want to supply something, either a gas or a liquid, anything. You need a connections. And everything would be there here. You have a band here, you have a valve there, just to control how much flow I need. You will have a pump there, you will have turbine there, several things you would have. So let's do one by one our calculation part, how to start our the designing or calculation of the pipeline. So let's say these are the two pipes. एक pipe ये है pipe A and the another pipe is pipe B, and these are connected by some means. Some means here you have several means जो आपको पहले पढ़ाया गया अभी just now. So you can put here a reducer here, right? So currently here you have a 90-degree change pair. So somehow you have connected the two pipes. So this pipe would also give the some loss. This pipe would also give the some loss due to their length of the pipe or the material of the pipe. Now here you have a fitting because by means of that you are connecting the two pipes either by welding, either by flange, or either by a the reducer, right? So you can have these so many combinations of the choices here, or by a union here you can connect here. Now you will have an inlet loss here. So you will have a here the entrance loss. This side you will have a exit loss, correct? You have a inlet, you have a exit. So two losses are there. One is losses caused by straight pipe, means by this length only, जो आपका LA है or LB. So if you will add the losses of only because of the length of the pipe, that is called the major head losses. Major head the losses means only because of the length of the pipe. Minor head losses means only because of all sort of fittings. जितना भी आपने फिटिंग ऐड किया है, elbow, thread, nipple, coupling, flange, gate walls and all this, all sort of the fittings apart from the length of the pipe is called fittings. Apart from the fittings, that is called a minor head loss. Okay, two terms are there, major head loss and minor head loss. Fine.
Yes, sir.
Now major head loss, if you want to calculate head losses between 0.1 to 0.2, you just add 2. The whatever head loss is being present in part 1, this is HLA, and whatever head loss in point 2, HLB, add them up, that is the total major head losses. How would you calculate these two? You have that formula FL upon D, B square upon 2G. So you can calculate this for pipe 1, this same formula for pipe 2, just to put all these parameters of the pipe 2. So in case of the series pipeline, just like the electrical circuit, total voltage loss, how do you calculate? You just calculate voltage loss in first wire and the second wire, add them up. Yes or no?
Yes, sir.
So same thing is being done. Voltage जो हमारे pipeline में होता है, that is called a pressure only, pressure drop. So voltage drop को आप यहाँ पे pressure drop से you can correlate. So your voltage loss from point 1 to 1 would be addition of the total loss between pipe 1 and pipe 2. So that's what you have the added. Same thing happen here as far as the current. So whatever current will you will insert at point 1, same current will reach to the point 2, right? That is the connectivity of the series combination property, correct? So same current will go to the point 2. So same thing here. The current in case of the pipeline is your volumetric flow rate or the mass flow rate. Fine. So your volumetric flow rate will remain same in pipe 1 also, point 2 also, because you are talking about incompressible fluid. So because from mass conservation, your fluid flow would remain same. So your current and flow rate would remain same. Your head losses would be added. This is the property of the series pipeline. What will happen in case of parallel? It will happen same thing as you will happen in your electrical circuit. So when two circuits are parallel, your voltage drop in each of the each of the connection would be
Same.
same. So therefore, if you will travel between pipe 1 here, L1, so whatever pressure drop between you have point A to B in pipeline 1, same pressure drop has to be there in this line 2 also, because both are connected at the same common point. Fine. So you will say in the parallel connections, your head losses would be same in all pipelines which are connected at two common points. Fine. So in case of parallel connections, your head losses will be equal in all pipelines. Only thing your flow rate will get distributed there. One particular whichever pipe would have the longer circuit here, you will have probably there you will have less current or high low current. करंट के बारे में कुछ बताएंगे? एक वायर बहुत बड़ा है, एक वायर छोटा है, कौन से में करंट ज्यादा जाएगा, किस में कम जाएगा?
सर जो वायर जो मोटी है तो उसमें से करंट ज्यादा जाएगा, रेजिस्टेंस कम
Yes,
मिलेगी।
because the resistance would be low, right? In that case, right? So same way you have here, whichever have the lower friction, there would give the more flow. Whichever will have high friction will give the less flow. And moreover, whichever length is more, in this velocity would be higher. Okay. By chance this length is low and this length is L2 is high, so this velocity would be higher compared to this, because the whatever fluid particle will leave from here at same time, they have to travel all the distances in same time, otherwise there would be a lag. Means यहाँ से आप दो लोग यहाँ से एक साथ जो है, if two people are the traveling from this point at the time t equal to 0, they should reach also at the same time here B. Okay, so that the person whoever will travel the longer path has to move at a faster velocity. Okay.
Yes sir.
So these are the two rules need to be followed in the series pipeline and parallel pipeline. So the series case, the losses would be added. In parallel case, your losses would be equal. Now this is what you can get the correlation, because if the losses are equal, so the loss formula is this FL upon D B square upon 2G, correct? So you can balance the loss in pipe 1. So if you are calculating for pipe 1, you are just putting the suffix here 1 1. If you are doing for pipe 2, you are just putting here 2 2. Equate that, you will get the something here, something like that. Okay.
Yes sir.
Now this is a
Yes.
typical example we want to proceed. So this is what is there. So first thing, let's say आपके पास this is your water tank or fluid tank. This tank is the lower than this top tank. So this fluid will not automatically reach to the point 2, correct? So you need some sort of the pump because it will not travel its own. However, if you want to take out fluid from point 2 to point 1, it will automatically come down because this is at the higher altitude, so it will come down to 1. But from 1 to 2, it cannot go its own, correct? So you need a pump. What this pump is doing? Pump is providing additional energy to a fluid which is present at point 1 to reach at point 2. Correct or not?
Yes, sir.
तो पंप जो होता है वो आपको फ्लूइड को एनर्जी प्रोवाइड कर रहा है जस्ट टू रीच एट ए डिफरेंट पॉइंट. सो इफ यू विल डू द एनर्जी बैलेंस एट दिस एंड and this end, so both are free surfaces. So if you want to write your energy balance, so this is pressure energy at point 1 P1 upon rho g. Kinetic energy is B1 square upon 2g multiplied by alpha. Alpha I taught you long time back is kinetic energy correction factor. Z1 is the altitude, or you can say the position of this. Then this much energy you are providing also at point 1. So whatever energy is provided by point 1, you are also adding at the left hand side. Make sure pump would add the energy to the left hand side, not the right hand side. Okay? Now at point 2, you will add your pressure energy, your kinetic energy, your potential energy. Now whatever is turbine क्या कर रहा है? Turbine is always extracting the energy of the fluid, so this should always add it to the right side. Turbine always extract the energy, pump always impart the energy, and whatever the losses are there, all the losses has to be added to the exit end or the point 2. This is how you have to use the energy balance. This is common equation. You have to always know that. This is the nothing great here. This is the nothing but your Bernoulli, but you are adding it for the non-ideal case. So you are adding here a kinetic energy correction factor, their pumps and everything. So you have added pumps. So most of the time, yes, bolo.
एच पंप यू और एच टरबाइन ई है, यू और ई क्या है?
No, you. Okay. Don't get confused with you and all this. Just leave the term you and all this. You is not there. Just don't get confused with the you and all this. Oh, okay. So
Okay,
this
sir.
is the power provided by pump in terms of height of the fluid. And this is power extracted by the turbine. So this is the thing. And this is all the losses including from point 1 to point 2. All the losses including major and minor both. Okay. Suppose now you see the point 1 and point 2. Please try to just listen it carefully because this is the basic concept that you have designed the pipeline. Point 1 and 2. These are the surfaces of your large reservoir. So there would not be any velocity change here of surface 1 and surface 2 if these are the surfaces of a large reservoir. There would be no change in velocity. Means you will not be able to find how much is the level change. If there, just like a river, have you ever seen there would be any change in the depth of the flow? Because the magnitude is too large, right? You cannot see. So in that case, your velocity at point 1, velocity at point 2 would be always equal to 0 in case of free surfaces of large reservoir. Okay, that is one thing to note. Second thing, point 1 and point 2 both are open to atmosphere. So everywhere point 1 and point 2 also, your pressure is equivalent to your atmospheric pressure. Fine.
Yes.
Now considering here inside this pipeline and everywhere, so in this case, if you will put this P1 equal to P2, this P1 P2 term will get cancelled. Your velocity V1 V2 both are equivalent to 0. This velocity would also will get cancelled. So you will end up with this equation in terms of pump. If this turbine is not there, so you will get head of the pump would be equal to Z2 minus Z1 plus HL. Correct or not? That's what you have calculated here. This much is the head, should be the head of the pump or energy provided by the pump. If you want to convert this head into the energy, you just multiply by QH rho G. Q is flow rate, is just V dot. H you have calculated H of the pump. Rho is the density of the fluid, and G is the G only, the gravity only. So that way you can calculate what should be my power of the pump. यहाँ से आपने पहले निकाला head of the pump, means how much height is being imparted by the pump in terms of energy of the fluid, and that you multiply by flow rate, multiply by density, multiply by G, you will get the power of the pump. That is your theoretical power of the pump. Now actual power of the pump would be calculated divided by the efficiency of the pump. So that would be nearly the 70% something. So that would be your actual power of the pump. Now this pump would be connected to a electrical motor. So electrical motor power would be your pump power divided by efficiency of the motor. So that would be your actual power of the motor. You cannot use the motor power of same of the pump power, because motor would also have some efficiency. You might have seen कभी कभी आपका मोटर जो है जल जाता है. Have you
Yes,
seen
sir.
that? वो ऐसी जो है
Yes, sir.
जल जाता है. Your pump power is too much high, motor power is too much low, so वो चल ही रहा है और पंप घूम नहीं रहा है तो जल गया फाइनली वो. It happens in that way. Or by chance your electrical motor power is excessive high, so pump को जितना excess power मिल रहा है कि it cannot survive, actually it cannot transmit that much energy to the fluid. Again, that in that case your pump will burn. So you have to make a combination of two very carefully. Fine. Now
Yes,
this
sir.
is the first problem we will show. Therefore, if you want to take, we can take a 10-minute break here, and then we will solve this problem, because all problems are same type. If you can solve one problem carefully by your own, rest of the designing calculation can be done carefully. So we can take a 10-minute break here. आप भी कुछ खा लीजिए, मैं भी खाता हूँ. Okay.
Okay, sir.
Yes, sir.
So we will meet at least we can meet at 2. Will that be fine?
Yes, sir.
Yes, sir.
Yes.
Okay, so we
Yes,
will
sir.
complete at least this question जो है मीन्स today, so that you can understand whatever I taught that today, we can use it that way. So we will meet at 2 o'clock.